name is Sheyshark06 and welcome back to more Learning Physics and Chemistry with Sheyshark. Episode 2. So anyways, we're gonna learn physics still today. We're gonna learn kinematics. Oh shit, I don't know whether you can see it, huh? Zoom. You good? Alright. So we're gonna learn kinematics. So what the hell is kinematic? Kinematic is just distance and displacement. If you don't know what displacement is, I'll explain it to you later. So before we learn about this distance and displacement, all this other stuff, we must learn about scalar quantities. Yeah, there are a lot of quantities: physical quantities, direct quantities, we have scalar quantities, and we have to learn vector quantities. Alright. So what's the difference between a scalar and a vector? Well, scalar is just like distance, speed, mass. That means it's like how should I paraphrase it? It's like they have magnitude. I don't know if you understand this. Magnitude, but no directions, no left, right, up, down. But for vector quantities, they have direction plus magnitude. So if you want to paraphrase it, I don't think this is correct. If you want to paraphrase, magnitude is like numbers. Yeah, if you want to, I don't know how to paraphrase this word, but still, this is for like distance. Distance, you can have no sense of direction at all. You can like this, then you can calculate the length of this, then you have the answer. So that means they have numbers, okay, but no direction at all, like this. Then we have speed. Does speed have directions? Speed doesn't have directions. They only have how fast you move. So therefore it has numbers but no directions. So that's the difference between scalar and vector. And what are examples of vector? Like I'm going to explain to you in a second. Displacement and velocity. Don't worry, I'm going to explain all this to you. Acceleration. I'm also going to explain to you. Don't worry, everything I'm going to explain to you very soon. Okay. And force. These are all vector quantities. We have numbers and directions. So there's all these are examples of vector quantities. So let me tell you the difference between distance and displacement. I'm gonna tell you what are they defined of and what the difference they make. So let's make two dots. Draw a line. I know my line sucks, but still. Mine sucks so bad. Then label it as point A and point B. Alright? Then we have one straight line. Yes, a line like that. Then we have one curvy line. And we have one straight line like this. So we shall name this line A. And name this line here line B. Then we name this line here line C. Alright? You guys understand so far? And line A has 10 kilometers. And line B has 7 kilometers. And line C has 5 kilometers. Alright? So here's the difference between distance and displacement. Distance is no matter what direction, regardless of direction. Okay, how do you say? Regardless direction of motion, as distance is a scalar quantities. Yeah, scalar quantities has magnitude but no directions. So if your teacher asks about distance, which line has the distance, you just need to say line A and C, cause it's regardless the direction of the motion. So anyways, they don't care whether it's like this, or anywhere. Just need to reach point A to point B, and that's called a distance. Well, for displacement, is just the most fastest path to go. The most fastest logic path to go like this. It's straight line. So therefore, displacement is 5 kilometers. Line C. So that means the difference between the distance and displacement is that the fastest way to get here to here. Because displacement is the vector quantities which has magnitude plus the sense of direction. So it means displacement can't go like this. Or only distance can. But displacement is just straight way go. Then here is a little bit of mind blowing here. This, however, if we have here, alright, people walking down this road, okay, arrow direction, right? Okay, so this is called a displacement. Then they make a U-turn. Alright, they make a U-turn. This is 3 kilometers. This is 5 kilometers. Then they make a U-turn. Then they stop here. Then what is the displacement? Well, if you say that it's 5 plus 3 equals to 8 kilometers, well, you are wrong. This is for distance. The distance covered by the boy. But we want displacement. So how should we find this answer to this displacement? It's simple. You just need to find 5 minus bracket. 5 minus 3 equals 2 kilometers. So this is the displacement. So beware about that, guys. Make sure don't get confused and everything about that. So how far are we? Alright, we are in 7 minutes. So anyways, yeah, actually yeah, we have covered one chapter already. This is just kinematics right there. Kinematics is just like this. Just remember scalar quantities, vector quantities, the distance between distance and displacement. Then you give you a question, do like this one idea tell you, and you're safe. You have finished covered one chapter of secondary 3 science physics. So anyway, since we still have time, let me give you more information that's not gonna be learned. Okay, as scientists, remember when I talked to you, actually wait, I didn't talk to you about that. Okay, anyways, let's see what I can say about here. Alright, let me give you a brief introduction about force. Since we got so much time, we can introduce you to force. Okay, what is force? Force is not like what person push you down like that. No. Force is just a push or pull. That's about it. You have defined force. Push or pull. But you can't write there your answer. I'm not just gonna give you wrong. Push or pull. How to define the real definition is this. If an object damn. Okay, never mind. You just write it's a push or pull. So there are many types of force. There are frictional force, which means your feet and the road friction is here. Friction force, like a ball rolling here, there's friction force around here. Right? Then we also have many other types of force. We have many other types of force, like tension between two persons. Like for example, if you pull a rope from here to here, and this here is tension. Then we have normal reaction. Like for normal reaction, like the cup is supposed to be standing still on top of a table. This is normal reaction. Yeah, I can count this even as a force. Then all this thing I just say is equals to contact force, which means it has it has contact with objects. For example, I put my hand on the floor, I slide it, it has friction. So that is contact. Now what about non-contact? We have gravitational force. Gravitational force. Okay, we'll write it down. Gravitational force, like how I drop my pen from here to here. That's gravitational force. We have electric force, like positively charged and negative charge, they link together, and positively charged and positively charged, they repulse each other. Then we have magnetic force. As simple as that. Same thing as that. It's like north and north, they repel, and north, south, they attract. So this is magnetic force. Yeah, so maybe this covers the basic thing that you need to know about contact and non-contact. It's about tension and all types of force. So I'm gonna go through this more when we in the next episode of Learning Physics and Chemistry with Sheyshark. So yeah, my name is Sheyshark 06, and I'll see you guys then.